But no big deal. I have only got my desktop on 2 backup batteries, and apparently both of them failed to keep my computer on for the 2 seconds the power went out and back in. Fun times. Okay, let's pick this back up before that happens again. And then I got to sort out why my UPSs aren't working. So we've got the suspected dead bricked logic board out now. We're going to connect our known good logic board with their display, just to make sure that it is in fact the logic board causing their issues here. Okay. And it would appear, yeah, all right. Seems that all this needs is that precious logic board replaced. So we'll go ahead and mark this one as bricked. Add it to the pile, make that 51 or whatever we're at now. And then we'll go ahead and date this so we know. The last one of the year. Wow. No, I forgot. I got a couple more actually. Shit. Okay. Before we just slap this back together, let's make it worth their money and time here. We're gonna crack it open just a little further here and see if this needs anything else replaced before we send it back. And what I mean by that is there are a number of common failures on these things, of course, and seemingly the most common one is no power. And that has nothing to do with our logic board here, of course. That is deeper down inside on the amplifier. And there's a batch of these diodes on the amplifier boards floating around out there that fail for no good reason. On the bright side, we do know which date codes of those diodes are failing. You just got to take it apart to see it. So let's do just that. We're going to see if this needs its Schottky diode replaced to prevent the no power issue. And then we're also going to test its DC filters, or its filtering capacitors. That's the second most common thing that goes out on these. And those, well, ceramic capacitors just naturally decay over time, so inevitably all of them need to be replaced, but we always check the condition of those filters and get them replaced if we see that they're out of spec. Now, how do you check that? Well, it's actually pretty easy. You can connect a speaker to the audio output of your amplifier, and you can do this with any audio amplifier. This isn't exclusive to HomePods. And you can take a multimeter with a DC voltage mode that's sensitive enough to read on a scale of millivolts, and connect your multimeter leads. It doesn't matter the polarity there. get them connected, and power the amplifier on. And what you're looking for is how far off or how far away from 0 you are. And most people in the audio world tend to say that 50 millivolts, give or take a couple, is about as much as you want to tolerate before you can start having an impact on the performance of the speaker and other sorts of issues. But as a matter of fact, the data sheet for the amplifier chip that was used is available for the PAL Radio IR4312M, something like that. And the manufacturer actually can tolerate up to 200 millivolts. Or technically, it's more like 18 millivolts on the input, which when you're testing, like we're describing here, on the output, that translates to upwards of 200 millivolts. Because, you know, amplifier. Thing goes in, thing gets amplified out. So, here we go. I've got my test subwoofer over here plugged into the amplifier now. And our test subwoofer actually has a connection to our multimeter that will pull up on our screen here now. And with this, there we go, we've got our number up on the screen. You can see that number move a little bit when I stab the subwoofer speaker. That means we've got a good connection there. Let's go ahead and power up this amplifier and see how good its filters are. And again, we're looking for less than 50 millivolts. Anything more than that warrants us replacing those filters, even though the amplifier can tolerate technically up to 200. We want to we want to be well ahead of issues. And I just noticed my YouTube chat is also broken. Let me refresh that. If you were chatting in the chat here, I did not see it, so you might have to chat the chat again. Alright, so we've got an excellent clean output of this amplifier sitting around 5 millivolts, and there's two things that are important here. First, that offset number here is relatively steady, and the second one is, the absolute value of that number. So you want it to be less than 50 millivolts, and you also don't want it to grow past 50 millivolts after sitting around. So we've gotten pretty good at being able to judge more or less how good or bad they are without leaving it plugged in for minutes or hours to see how much they grow. We can pretty much tell by their behavior within a few seconds where they're going to be. And this one looks to be in excellent shape. So we're not going to bother messing with the filters on that. It's kind of like changing the oil filter on your car when it's still pretty much brand new. There's no real point in doing it. The other thing we're going to check is that Schottky diode and shoot. It does have a date code of 1746K on it. The two date coded diodes we're looking out for are 46K and 48K. So those are the two that fail all the time and cause no power. Let's get that amp out and nip that problem in the bud. And this isn't something that your average repair shop's gonna know to need to do or to even look out for. We've seen enough of these diodes with those particular date codes failing and causing no power and especially with James here paying as much as he is for the repair for the logic board, it would be really, it'd be kind of bad in a lot of ways for us to turn a blind eye to the fact that there are a couple of other components we know are bad and gonna fail in this just because we got it working again with the logic board here. So got that out. if you've never watched one of our live stream repairs before, then this will be a first for you. But if you've tuned into any of them in the past, then this will be a sight very familiar to you guys. There's our Schottky diode, and there's the date code 46K. That's week 46 of the year 2017. So week 46 and week 48 are the crappy ones. Let's get that replaced, and then we can sleep easy at night knowing that James here will get a working HomePod that isn't bricked, but also won't just suddenly stop powering on in the near future. It's just really crazy still that we've been at this for over 2 years, and we're still almost on a daily basis getting anywhere from 2 to 4 on average. Most of them are still this same exact diode failing and causing no power. Alright. We got the old one off. Give me 1 second here. Sorry, just coordinating with a local fellow to get their HomePod dropped off and fixed. And you can probably guess what their issue is. No power. And you can probably guess what we're going to be doing to fix it. The exact same thing we're doing here. And that's exactly why we're doing it. And it frustrates me to no end that undoubtedly Apple is aware of the failures going on here. And regardless of the overall number of people affected, relative to how many units were actually sold, like let's say that 1% of a million units out of the 2 or 3 million units sold. I have no idea, but let's say that 1% out of those 2 or 3 million units were defects. Oh, that's still a shit ton of... That's still a lot. That's still more than we've personally fixed by ourselves. But, it's hard to talk and do this at the same time. Sometimes I just end up rambling off and in no sense. But anyways, regardless, we've done so many of these by ourselves that there's undoubtedly enough units out there that they should be recalling them. They should be recalling these regardless of how many of them were affected. We've seen enough of this. There's enough people complaining. But I just don't think it'll ever happen because ultimately there just weren't enough first-gen HomePod customers. And out of those first-gen HomePod customers, there weren't enough of them making a stink. Goodness. Have I opened a new... Okay. Hey, welcome to the chat. The Pwig? The Pwig? It's an interesting name. Have I opened the new model HomePod and seen the different circuit board design? I have 2 teardown videos of the new 2nd gen HomePod. On my channel, I have a teardowns playlist that you can find those in. And from what we can tell, it looks like they fixed all the kinks in the 2nd gen. I mean, first of all, they use a new and beefier Schottky diodes, so the no power issue is long gone in the 2nd gen. And then death farts, it's hard to say because we can't quite tell how the amplifier was designed yet still. My brain is still just a little too smooth to be able to pick up a random board and be able to see the entire, understand what each component is doing and what it's responsible for. That's some big brain stuff. But there are some obvious improvements they made that seems, so far at least, to be holding up well. Only time will tell for now if they will have the same problem ultimately over time, since, again, all ceramic capacitors naturally decay over time. So whether they designed the amplifier with some sort of ridiculous bit of redundancy that makes them last more than a few years at a time, who knows? I couldn't say yet. And then of course you've got the you've also got the ones that are bricked, the one that we're fixing here with the blinking volume buttons or boot loops, software issues generally. As far as we can tell, Apple still hasn't given end users any way to recover or restore the software on the bricked 2nd gen HomePod, same as the 1st gen. And just like the 1st gen, on the bottom of the HomePod, if you remove the base, there is a diagnostic port. Although it's actually in the shape of a circle on the 2nd gen now, unlike the way that they have it on the 1st gen. Presumably it's got the same kind of USB and UART or UART access that the 1st gen gives you through those pins, but we don't know yet what the pin out of that would be. But based on, it does seem easier to remove the rubber base or the plastic base on the bottom of the 2nd gen, a lot easier than it is on the 1st gen. So I do imagine they've at least given Apple stores and Apple technicians the ability to restore the software on those bricked ones, which is, it makes me salty because it's like, well, why won't you allow end users to do it? Because you're going to want to charge them out of warranty replacements if they're out of warranty, and claim it's a hardware issue or some other bullshit. I don't know. You just want to keep it to yourself. Well, let me tell you, Apple. Nobody liked that one kid in school that never shared their shit. And if you and if you're not gonna give it to us, someone's gonna figure it out one day. It might not be me. It probably won't be me. but someone's gonna figure it out. And then the jig is up. Oi. Okay. There we go. All right. All right, we got our good logic board. And James is extra lucky today. They get a logic board that comes from the same color. It's not often I have a choice in what color the logic board I have available for someone's brick to repair may be. It's that bad. I really wish it was easier. I would love to only have to charge $20 to $40 to repair a bricked HomePod, because all I would have to do is rip the rubber base off, plug it in with my little dingle dongle here, and then click restore on my Mac. It's just, there's already a restore button. You can already do this. There's already a restore button. It's all built in. It's ready to go. It wants to let you. But Apple's software servers just do not give us access to the IPSW. It's just so strange, because you can do this with any other Apple product, right? You can do it with the HomePod Mini. You can do it with your iPhone. You can do it with your MacBook. And I get it, not every user is going to want to rip apart the bottom of their HomePod to restore the software on it, but how many do you think will? I'll tell you, it's a lot. And it's not just that, it's a simple, trivial little matter creating so much waste and resources and landfill. Like $250 it cost them to make every single HomePod. And they're throwing these things in the trash because of software. It's a speaker. It's a speaker. Come on. Just let me use it as a speaker at least. Even as a limited HomePod, let me use it like that. Good. You guys want to see this drawstring BS? That one actually went pretty easy. Ugh. There we go. YouTube puts this like emoji pop-up in the chat, but it covers up half of what people say, so I can't see what they're saying. Let me see if I can fix that. Nope, it's just like that. But I think they're saying that they sent their HomePod in to me. Sent you my HomePod. Okay. Yeah, we'll be fixing these for forever. I don't foresee ever stopping the fixes in fixing these up. At a point there, you know, we won't be able to source replacement parts for certain fixes or for certain issues, like, you know, the bricked ones. It'll have to get to the point where we're replacing the internals entirely with something else to drive the speakers, which I've been looking into a lot. The challenge is finding, because I'm being very particular about what I want to cram in here if we're going to rip the stock guts out and replace it. I want an amplifier that's small enough, obviously, to fit inside of here, with AirPlay 2 support still. That's an absolute hard requirement. It has to have AirPlay 2. And so that already automatically disqualifies a lot of off-the-shelf options out there, but there's still a few. The second challenge is dividing up the odd number of mid/tweeter speakers, since there's 7 of those, between the left and right channels. I've been thinking, well, we could probably just like do some, there's a few different options. It depends on what amplifier you get. They give you the option to configure left and right versus mono on each channel output of the board, which would be really nice, and that gives people a lot of flexibility if they want to set up multiple in a living room and set up some true multi-channel stereo. Well, enough blabbering around. Let's see if this thing works. Anyways, yeah, I'm looking at long-term usability of these and trying to figure out how we can stop relying on these and how we can move on to something that's going to be a little smaller, like this. So nothing quite exists yet that's as a complete and easy solution as I'm looking for. There's probably a few things out there we could piece together, and if we have the time, we will certainly be coming up with something like that to hold us over until nicer options come out. But hey, look at that. We've got James' HomePod all fixed up and working again. So we've got to ship a couple HomePods out today and go pick up some more, and we might be back later this afternoon/evening to fix up some more. So hope you all enjoyed this live stream repair. If you want to catch some more, feel free to subscribe, and I'll catch you in the next one. Bye.